In this lesson, we're going to have a look at applications of polynomial functions with a special focus on cubic models. So let's straight away jump to our first example. So we've been given a square sheet of tin which measures 12 by 12 centimeters. Right? They want us to form an open rectangular box with this sheet of tin metal. Right? So what they've suggested us is that we cut 4 equal squares of each x centimeters from each of the 4 corners to form this rectangular open box. Right, the first question for us we have to think about in this particular case is, what are all the possible values of x? Right, that's going to be our first question before we even get started with this question. Right, so the length and width of the sheet of tin is 12 by 12. Right, so and I'm cutting 2 squares, one from each corner if I consider the length, and similarly if I consider the width, I'm cutting 1 square from each corner. So which means the maximum possible value of x has to be less than 6 centimeters, right? Because if I cut a square of 6 centimeters, what does that mean is I'm going to be left with nothing left for the length or the width of the rectangular box. On the other side, we also have to consider the minimum possible value of x. Now, for us to form a rectangular box, the minimum measurement for x has to be greater than 0 centimeters. Obviously, if I don't cut a rectangle or a square at all from each corner, I'm not going to be able to form an open rectangular box, right? So what I can conclude is the maximal domain or the maximal possible values of x in this particular example is going to be between 0 and 6, both of which are exclusive. So now that we've established what values x can take, right, we're going to start and form some expressions to form this rectangular box. Right, so what I'm going to do here is I'm just going to draw in a rectangle or in a square, which is going to become the base of our open rectangular box. Right, so I'm going to cut squares of x centimeters from each corner, right, which means the new width for this particular box is going to be 12 minus 2x centimeters. Right, similarly, if I'm going to cut for the length or the width for this particular case, that is also going to be 12 minus 2x centimeters. Right, now the question is obviously asking us to focus on the volume of the box. Right, so the first thing I'm going to establish is I'm going to bring up an equation for the volume of this rectangular box. Right, now volume of a rectangular box is going to be equal to length times width times the height. Right, so which means in this case we've just established the rectangular open box is going to have a length and width of 12 minus 2x centimeters. So which means it's going to be 12 minus 2x times 12 minus 2x. Now let's think about the height of this rectangular box. Right, now the height of the rectangular box is going to be the side length of the squares we cut, right, because that's what's going to fold in to form the box, which means the height of the rectangular box is going to be equal to x centimeters. Right, so now that we have established an equation for the volume of the rectangular box, there's a couple of things we could do. Right, we can expand the scenario. We can also basically try and sketch this in the form of a cubic function. So obviously let's start with, if I go ahead and sketch this as a cubic function, right, what I can see here is minus 2x times minus 2x times x is going to give me a positive 4x cubed, which tells me that this is going to be a positive cubic function. Right, so that's that indicates to me that's going to be a positive cubic function. Now if I consider my my y-intercept, right, so if I consider my y-intercept, right, we make x equals 0 as That's the first step for finding the y-intercept. And if I make x equals 0, I can see that the volume of the box is going to be equal to 0, right? Which means that it is going to pass through the origin, which is also one of the x-intercepts. Now, if I look at the x-intercepts for this particular scenario, right? So if for finding x-intercept, we make y equals 0, right? Which means I'm going to have 12 minus 2x, 12 minus 2x times x is equal to 0, applying null factor law, right, which means 12 minus 2x is equal to 0, or x is equal to 0. Now solving for x in this case is going to lead us with x is equal to 6. Right, obviously because we've got two of those brackets, x equals 6 is going to become a repeated factor. Right, and when we go ahead and sketch a repeated factor, remember it is going to become a turning point in this particular case. Right, so let's do a rough sketch for this particular scenario. Right, so I've got my y and x intercept. Right, I'm going to mark my origin. Right, I'm also going to mark my 6, which is my another x intercept. Right, so if I sketch this cubic function, it's going to be roughly looking like that. Right, where that point becomes a turning point. Right, now let's go back to the question. Right, the question is in two parts. Firstly, they want us to find the value of x for which the volume is 100 centimeter cube, right? So let's go to part A, right? So they're saying the volume is equal to 100 centimeter cube, right? So which means 100 is going to be equal to 12 minus 2x times 12 minus 2x times x. Right, now to solve for this, we can use our CAS calculators to solve for this, or if you want to solve it by hand, obviously you've got to expand the brackets first, bring all the terms over to one side, and you might end up getting a cubic function which you would have to factorize then. Right, so in this case we're just going to use our CAS calculator. So we're going to go open up a calculator page, right, menu, algebra, solve, right, 100 equals brackets 12 minus 2 times x, come out of the bracket, put times again, 12 minus 2 times x. You might also like to do 12 minus 2x to the power of 2, that is also fine, times x, and again we're trying to solve this for x. I'm going to do control enter, right, gives me three values here, x is equal to 1, x is equal to 3.21, and x is equal to 7.79. So I'm just going to copy that down in my sheet there. So x is equal to 1, x is equal to 3.21, and x is equal to 7.79. Right, now this is the length of the square boxes that we're cutting from each corner. Now we've already established the fact that the maximum value for x has to be between 0 and 6, right? So what that means to us is, if I go back to the three values we've got, right, obviously that means I can eliminate x is equal to 7.79, so which means the two possible answers in this particular case is going to be x is equal to 1 and x is equal to 3.21. Now let's go to part B of this question. Now part B of the question basically saying what is the maximum volume of this particular box, right? Now let's go to the sketch that we've just drawn, right? The sketch basically is x on the x-axis. Now the volume is what's going to go on the y-axis. Now we've talked about in this particular case a realistic value for x has to be between 0 and 6, right? What that tells me is I can basically decide to ignore this part of the graph, because for this part of the graph the value for x is greater than 6, right? And which means we don't have to take it into consideration. Similarly, I can also tend to ignore the graph on that side of the x-axis, of the y-axis, right? Again, because it is outside the maximum value that x can take in this particular scenario, right? Which brings me to the focus part of this particular question, right? Which means the only bit I've got to focus on this particular question is this particular section of the graph, right? And obviously I can see that this one actually has a maximum somewhere there, right? So what we're going to do here is we're going to go ahead and sketch this in our CAS calculators, right? So I'm going to go open up a graphing page, so Control DOC, right, opening up a graphing page, entering the equation times 2 times x. Now this time I'm just going to save some time by making that a square, times x. I'm going to press enter. Obviously I can see that I can't see the whole of the... Right, there's a few things we can do. We can go into menu, go into window, and let's do zoom out. Right, I'm going to zoom out by clicking the center button. Right, obviously I can see that I have my maximum somewhere there. Now you've got to press the escape button to get out of this option, so press the escape button. Right, we are focused on the maximum somewhere there in that graphing page. Right, now I can see that this particular graph is actually nicely fitting itself with the maximum somewhere around the 140, 145 mark, right? So I'm just going to do a little bit of adjustment just to make sure I can see the graph more clearly than what I can see at the moment. So I'm going to go into menu again. I'm going to go into window. This time I'm going to go into window settings, right? So we've talked about the minimum and maximum value for x. So the minimum is going to be a 0, right? Maximum 6, that's what we're going to accept in this particular question, right? Similarly, when it comes to the y value, which is nothing but the volume of the box, the minimum volume of a box has to be 0. And just by looking at the value earlier, I can see that the y value, or the maximum y value, is going to be somewhere around the 140 mark. So I'm just going to go a maximum of 150 there. I'm going to press enter, right? As you can see, once you've set out our window settings, we can see the graph a little bit more clearly, right? Once you've done that, right, I'm going to go back to menu again. I'm going to go into analyze graph, right? And because we're trying to find the maximum, I'm going to select number 3, which is the maximum, right? And obviously, we talked about this earlier, one click on either side of the point we're trying to find, right? Which has given me the coordinates 2, 128, right? So now let's go back to my question. Right, my question basically is asking me to find the maximum volume of this open rectangular box, right? So I can simply say the maximum volume is going to be 128 centimeter cube, right? Now at x is equal to 2 centimeters, right? What this means by that is when we cut the cut squares of 2 centimeters from each of the 4 corners, we end up getting a box which has the maximum possible volume in this particular scenario, right? And with that we complete this question. Right, let's go to a second example, right? Slightly different one. In this case, let's read this one to start with, right? It is found that 250 meters of a path of a stream can be modeled by the cubic function, right? They've given us some information about the cubic function. Is passing through 4 points, 150 and then 200, right? The first part of the question saying, hey, find the equation of the cubic function, right? So obviously we've been given 4 points, so we're going to take our cubic equation in the form of y equals ax cubed plus bx squared plus cx plus d, right? So, and then we've got 4 points, so which means when x is equal to 0, the value for y is equal to 0. Right, I'm just going to rename this as f of x, so it just makes it a little bit more clearer. When x is equal to 0, y is equal to 0. The second point saying when x is equal to 100, it is equal to 22. Then the third point states when x is equal to 150, the value of the function is minus 10. And finally, when x is equal to 200, the value of the function is minus 20. Right, now with that behind us, let's quickly go to our CAS calculators. Right, we can try to solve this by hand, but in this particular scenario I'm going to use the help of the calculator to solve for the values for A, B, C and D. Right, so I'm just going to open up a calculator page. Right, we're going to go into menu, actions, and we're going to select define. Right, I'm going to define f of x, so f bracket x equals, now when we're typing in the cubic polynomial, right, we need to make sure we're entering the times symbol wherever it's applicable. So what I mean by that is we're going to go a times x to the power of 3 plus b times x to the power of 2 plus c times x plus d, right? Now, entering the times symbol is really critical, because if we don't do that, what the calculator tends to do is, for example, if I take c times x, if I don't enter the times symbol, my calculator is going to consider cx as one variable rather than c times x, right? I'm going to press enter, right, which means I've defined this polynomial. Now let's go back to menu. This time I'm going to go into algebra, solve system of equations, solve system of equations, and right, we got 4 equations, right? Our alphabets are A, B, C, and D, right? I'm going to press enter, and we're going to enter the 4 equations. So f of 0 is equal to 0. Right, the second point is going to be f of 100 equals 22. Right, so f of 100 equals 22. Then we got f of 150 equals, I believe it's minus 10. I'm going to go back and double check that. Right, and then f of 200 is minus 20. Right, so we got f of 200 equals minus 20, right? So we've just basically entered all the 4 equations in a simultaneous equation scenario. I'm going to press enter, gives me the value for A, B, C, and D, right? I'm going to try pressing Control Enter to see what I get, right? Okay, I've got the values for A, B, and C in the form of a fraction, right? I'm just going to go back to the question to check if they mention anything in here, right? Given the fact that the answer has not been mentioned in terms of whether they want as a decimal value or an exact value, we are going to prefer the exact answer, which is going to be the previous step here. So we're going to take into account the exact answers as it is mentioned here. So I'm just going to go ahead and copy that down, right? We got A equals 19 over 375 000. B is equal to minus 23 on 1250. The value for C is 233 on 150. Right, and the value for D, obviously in this case, is equal to 0. So D is equal to 0. Right, I'm just going to try something here. I'm going to open up a graphing page. Right, I'm going to try to sketch f of x. Right, obviously that's asking us to create a slider, so it didn't quite work. Alright, so what we're going to do now is we basically have to, because the second part of the question is actually asking us to find the maximum deviation of the graph from the x-axis between 0 and 250, right, which means we do need to sketch this function in our calculators, right, so which is going to be a little bit of a tricky part. So right, so we're going to go Control divide. Alright, let's remember the values again. 19 over 375 000 times x to the power of 3. Right, the second value is going to be minus 23 on 1250. Right, minus, I'm going to do Control divide again, 23 on 1250 times x to the power of 2. Now plus, I believe this one was 233 over 150 times x, and because the value for D is 0, I'm not going to bother entering that. Pressing enter. Right, obviously I can't see the whole graph yet, so I'm going to go into menu again, window, and then I'm going to go zoom out to start with. Right. Right, so I can see the graph pretty similar to the one given in the question, so I'm happy with that. So I'm going to press escape. Now the question here is asking us to find the maximum deviation, right? So maximum deviation doesn't necessarily mean the maximum of the function, right? They want us to see how far the stream basically is away from the x-axis, right? So which means we really need to find both the points and see which one's further away. Although just visually I can see that this particular point here is probably further away from the x-axis in comparison to the other. So we're going to go ahead and find those 2 points. So number 6, which is analyze graph. This time I'm going to start with the maximum. Right, one click on either side of the maximum. Right, go back to menu, analyze graph. I'm going to select the minimum in this case. Right, 1 point on either side of the minimum. Right, now again, the deviation, which is basically referring to the y value in this case. Right, the maximum is 38.2 units away from the x-axis. The minimum is 21.6 units away from the x-axis, which means the maximum deviation is 38.2. So let's go back to the question again, right? Now again, I just missed something here. The question is saying find the equation of the cubic function, which means we are basically required to write it in the form of an equation, right? So 375,000 x cubed minus 23 over 1250 x squared plus 233 over 150x, right? That completes part A, and we've just figured out the maximum deviation is equal to 38.2. Right, I'm just going to go back and check if there's any units mentioned. There is no units mentioned, so I'm just going to happily leave it as 38.2. Right, with that we come to the conclusion of this lesson. Thank you for listening and have a wonderful